My name is Isaac. So in the past 2 weeks, I was working on this project. I tasked myself with helping users understand LDOF filters and also create them. An LDOF filter allows users to make a search in a very powerful manner. So these are some examples of LDOF filters. And there are infinite combinations of them. So we can parse these easy examples using regex, regular expression. Unfortunately, an LDOF filter can also take the form of a combination of LDOF filters using AND, or not operator. So this is where the regex fails in because we have recursion. So here's another one. So you have two options. You can either try to implement regex plus recursion yourself and risking introducing bugs, or you can try to use something else. So the things that handle these kinds of expressions are called context-free grammar, and Nearly is just one of the many parsers that handles context-free grammar. In fact, Nearly helps us solve 5 problems all at once. So the first one I call recognition. It's the very purpose of tools like regex and Nearly. Given a string, is this a valid LDOF filter? These 3 are not valid, and this one is. The second problem I call classification, meaning that I want to know why something is an LDOF filter. So can you explain me? I know that this expression is a valid LDOF filter because it is a simple expression. This one is a valid because it's a present expression, and so on. So you can classify each expression, and because you can classify it, you know it is valid. And there's a converse problem. If something is not valid, I also want to know why that is not valid, right? So here, the first two. The first one, I'm missing an equal sign, so that's not a valid filter. Here I have a space, and here I'm missing a number. So I want to be able to tell the users why they did something wrong. Fourth is transformation. So instead of just a simple true or false, meaning is valid or not valid, I want to be able to output a rich, easy to digest structure and content so that I can use this for the UI side. And then lastly, and perhaps most importantly, is maintainability. If you write this grammar code today and come back to it later, I should be able to easily understand just as I was on the first day, right? In fact, Nearly can help you produce kind of railroad diagrams, meaning that you can substitute an attribute with this, an operator with this part, and the value for this part, and you can kind of visualize what's happening with your grammar. And compare this to regex, you might understand what's happening here on day 1, but if you come back on day 10, you might not understand what's happening. So given these problems that we want to solve, I'm going to give you a concrete example, and that's, again, the LDOF filter that I was working on. Okay. For simplicity, instead of using the full definition, I'm just going to define an LDOF filter as the following. It's an expression that is surrounded by parentheses. So let me define next what is an expression. An expression can be either simple or present. So let's next define what is a simple expression. A simple expression has 3 things: an attribute, an operator, and a value. So let's, again, keep going. What is an attribute? Again, for simplicity, my attribute only consists of letters, numbers, and underscores. An operator can take one of these forms. It can be equal, similar, greater, or less than. And then the value, again, for simplicity, I'm just going to consider letters, numbers, and underscores. So I've defined my simple expression. The last thing I have to define is a present expression. Present expression is just an attribute followed by equal star. Okay. So you might have noticed that I've color-coded these things. The things in white, they're called terminals. And the things in yellow, they're called non-terminals. So terminals, think of these as atoms in chemistry. They're like the building blocks. You cannot further divide atoms into smaller things, unless you count subatomic particles. But for my analogy, they don't exist. And then things in the yellow, the non-terminals, they're like compounds and molecules. They're built upon the terminals through specific rules, right? So keep that in mind as you write the code. So initially, I was going to do a live demo, then I realized it's a terrible idea, especially when I finish this presentation today. So I'm just going to show you the code. I created a new Ember app, and in total, I'm going to modify 6 files. I'm going to create a utility file called LDOF filter, builder, I have a grammar file that ends in the any extension. It lives in the vendor the folder. And I have a script to easily compile this grammar. And then I'm going to modify Ember CLI build so they can actually use the compile asset. So let's take a look at the shell. To make the Nearly work in an Ember app, you have to globally install Nearly and browserify. This script just creates a compile file. So let's just skip this. Just skim over this. Because we have a compiled file, if you want to use it in an Ember app, you have to tell Ember that this file lives in the vendor folder. So here's the change there. The utility file is very simple. I just have a try expression that says, try to parse a given input and see if it works. If there are results, I'm going to return the first result. Otherwise, if there have been an error because there was no match, just return a false. Okay? Just either some kind of object or a Boolean false. Okay? And here's my grammar file. So this is where I think the advantages of Nearly really shines in. The code that you write is pretty much the copy paste of what the slides that I've shown you, right? Starting from the top, I define what a filter is. A filter is an expression surrounded by parentheses. An expression is simple or present. Simple is these three, and so on. All the way until you get to probably the terminals. And here's my present definition. So the code is very self-explanatory, but there are some the new syntaxes you probably encounter. So the first thing that you probably see is this curly brace ampersand followed by the closing one. And inside of a function, and you'll see that for each of these, I've defined this kind of a syntax here. So in Nearly, this is called a post processor. A post processor takes the outputs from the non-terminals here and you can transform them into something meaningful for you, the output of the outgoing non-terminal simple. So for the case of simple, what I've done is I've taken the matches attribute operator and value. I tried to concatenate them and store the result in an attribute called expression. At the same time, I tried to store some more data just in case I might need to use them later. So I'm storing the expression type as a simple type. I'm storing the attribute, the operator, and value, and so on. So the thing to keep in mind is that Nearly, by default, what it outputs is an array. And the reason it outputs an array is because it can potentially produce multiple results. It's called ambiguity. And if you have an array, it doesn't matter how many ambiguities there are. Right? There can be just one result, or there can be multiple results. It doesn't matter. So that's the reason it returns an array. But for us as developers, we might be more interested in the actual content inside the array, right? So that's why I have these ID statements here. I think it stands for identity. And what it does is it just returns the first element in the array. Okay. And by modifying the outputs, so by taking out the first content of the array as soon as possible, I think it really helps you keep track of the type of the output you're making. So I know that this, for example here, equal sign, ampersand id, I know that the result of this output, if it matches, is just a string that has the equal sign. And because I know that it is a string, when it's time to combine them, I know that this is a string and so on. So this really helps me do type checking. Okay. At the end of the result, at the end of the parsing, it's just an object. If it is a match, if it is a simple expression, it'll return this object. If it is a present expression, it'll return this object. And that's the nice thing about Ember, right? You can write tests to make sure that your grammar is correct. So what I've done is I've created a utility file so I can easily make a unit test for the grammar. So here in this public repo, I just have 5 tests, making sure that all of my simple expressions and all of my present expression, they are correct. Okay. And then let me show you the demo side, so the actual UI. Okay. So first, I'm going to try to create a filter, and then secondly, I'm going to try to edit an existing filter. So these are the things that users might want to do, right? So first, let's see, let's type A is equal to B. It's a simple expression. I can also try to combine expressions, remember, combine filters. So let's try to do that. Okay. So visually, it helps the users understand that there's some kind of grouping going on. If I wanted to change this this individual expression in the group, I can do so. I can also turn it back into an individual expression and so on. And because I'm checking for, remember the third thing is I want to do error handling. I want to be able to tell the user exactly what is going on when they make an error. And as the last thing that I want to show is that the editing is also easy. So what I've done is, what I'm going to do is I'm going to copy this complicated expression and see how fast we can render it, and of course, and see if if it helps the user understand what's going on. So you see the structure very easily. And again, you can modify it to your heart's content. Okay. Any questions so far?
No, it's neat. Cool.
All right. So the last thing that I want to cover is the best practices. So based on my experience working with LDAP for LDAP and Nearly for the last 2 weeks, I have 5 suggestions. So the first thing that I want you to do is to obey the rules, the grammar rules. Follow them very strictly. What I tried to do initially is LDAP filter, they're really strict on spaces. So what I try to do is allow the user to add spaces to their heart's content, right? Because that makes it filter more readable. But unfortunately, that turned out to be not a good thing to do because the value can actually have spaces, and with the values, the spaces actually have meaning. So it's really hard to parse them. So when it's time to make a grammar, to write the grammar, follow the rules very strictly. And the second step. So this is if you were to try to insert spaces, don't do this. The second step is to write the test. So once you've written the rules correctly, write tests for them to make sure that your grammar is correct. Then what you might consider is try to relax the rules. So this might involve like inserting, allowing the white spaces. It might allow more filter types, more operator types, if you will, just in case they make a mistake and you want to allow them, right? So for example, what I've done is this. So this is the rule before. I can modify as follows. So in the regex world, the question mark means 0 or 1. So using this question mark symbol, I can test whether an attribute, an operator, or value, whether they're present or not in my expression, right? And if attribute doesn't exist, I can show an error message that says, hey, you're missing an attribute. Please fill it out. So I can relax the rules a bit, but there's a downside. This might introduce ambiguity. And ambiguity in the Nearly world means decreased performance. But if that's not a problem for you, if the user experience is what you're more focused about, then go for it. And the fourth step is to write more tests. Now that you've relaxed the rules, see if you can write tests for the relaxed rules and see if they pass. And then finally, refactor your code. By the time you've written like the correct rules as well as the relaxed rules, your grammar file is probably a mess. So take the time to actually refactor it. This might involve renaming the variables to something that's more meaningful. It could involve writing helper functions and getting rid of the repeated code. So in summary, what we've done is we looked at an alternative to regex, especially if you have a context-free grammar, like LDAP filters. For more information, I invite you to visit my blog. The script is there. You can also check out the repo there as well.